Polyvinyl chloride, or PVC, is a thermoplastic, which is the third most widely used plastic around the world. Due to its many useful characteristics, PVC should be manufactured on Villanova for the reasons presented in this video. Polyvinyl chloride is derived from salt and oil. First, ethylene dichloride is created from chlorine and ethylene. The electrolysis of salt water produces chlorine. This is when salt water flows from an electrical source of copper wires and the positive and negative ions separate to form chlorine. Ethylene is produced from steam cracking crude oil. This is taken from feedstock, specifically ethylene. The crude oil is diluted with steam, then brought into a very hot furnace where the hydrocarbon bonds break into smaller bonds, forming ethylene. At very high temperatures, ethylene dichloride is converted to vinyl chloride monomer. It is then polymerized by reacting the vinyl chloride monomers together to form polyvinyl chloride. The creation of the polymer is a condensation reaction because there is a removal of water through the creation process of salt water to chlorine. The chemical structure of PVC is polar. This is because it contains a carbon-chlorine bond, which is polar bond because it has an En of more than 1.4. It is also asymmetrical because there is an imbalance with the chlorine and the other hydrogens. The PVC structure contains a halogen of chlorine. Also, with the presence of a cross-linking agent, there is cross-linking. Cross-linking links one polymer to another. PVC is a great plastic to produce on Villanova because it is durable, inexpensive, and resistant to heating chemicals, compatible with other additives that can provide PVC with clear or colored appearances. It is also excellent for electrical installation purposes, and PVC is chemically stable and does not depolymerize. PVC is beneficial long-term since it has such strong bonds and the plastic is durable and lasts a while. It can be recycled and used up to 50 years. PVC has a variety of uses in construction especially, included in flooring, windows, and door frames, water and waste pipe, electrical applications such as cables and wires. PVC is also used in clothing because it is cheaper than latex, leather, and rubber. However, most of PVC plastic is used in manufacturing of pipes. PVC is a thermoplastic, so it can be melted and reused. The recycling symbol is PVC3. However, it is not biodegradable, meaning it doesn't disintegrate. This isn't a huge issue, as most plastics don't because it is very recyclable and lasts a very long time, which makes it economically feasible. When recycled, PVC needs to be sorted separately. Since PVC is mainly construction materials, it is less likely to end up in the ocean and in the environment. It is typically used in materials that remain in one place, such as pipes and wires. It doesn't give off gases or release harmful chemicals if it comes in contact with water. And PVC manufacturing process does not require a great deal of energy, and PVC is lightweight, thus it cuts down the carbon footprint in shipping the products. Even as PVC releases dioxin, hydrochloric acid, and vinyl chloride, it is not a major contributor to air pollution. In America, there has been a sharp dioxin decline by 80%, even as the PVC production has skyrocketed by 300%, as represented in the graph. This shows that the creation and decomposition of PVC is not a major contributor to the pollution of this toxin. Additionally, the chlorine used in PVC production, which is sodium chloride rather than chlorine gas, poses no more of a health threat than the chlorine used to purify water coming from your household tap. This is a biological compound. Overall, PVC should be produced on Villanova. Due to its durability, accessibility to the materials needed to produce, Villanova will need PVC to make construction materials required for the island. These materials will be cheaper to produce, accessible from the oil refinery and the ocean, and lighter weight than the alternative materials.